This section looks at the domain of a function. Now, the domain of a function, recall, is all the x values or the inputs that we can give that function. When we were looking at domain before, we were given graphs and we looked at what x values that graph allowed us to be. Now, what we're going to do is we're actually going to be given just the function and not the graph, and we're going to find the domain of that function. Well, how do you do that? To start with, we're going to begin by assuming that the domain is all real numbers. So unless you have an issue, your domain's all real numbers. So you assume the best out of every function you see. Then you're going to determine, do I have a place where this function is not defined? Do I have issues? The only two kinds of functions that give us issues are rational functions, so functions that are fractions, and the reason for that is because division by zero is undefined. And the other type of function is an even root function, and that's because we can't take the even root of a negative number. We're going to get an I, and as we know from previous sections, you can't graph an imaginary number on the Cartesian coordinate system. So let's start by looking at how to find a domain of a function if I had a rational function. So we're looking at a function, we'd assumed the best, but then we realized it's a fraction, so what would we do? How would we find the domain of a rational function? Well, we've done this before when we were talking about rational functions, but let's review it again. To find the domain of a rational function, what you need to do is set the denominator equal to 0 and you solve for x. Any real numbers you obtain have to be excluded from the domain. So the domain is going to be all real numbers except where the denominator equals 0. And again, really what you're doing is you're going to exclude the real numbers you obtained when you solved for x. So any real number you get when you solve for x has to be excluded from your domain. Let's look at the first two examples. It says to find the domain of the following functions and write our answers in interval notation. So, number one, f of x is equal to x over 9 minus x squared. Well, this is a rational function, right? Because it's a fraction. Here's my fractional bar. So to find the domain of this function, I need to set the denominator, which happens to be 9 minus x squared, equal to 0, and I solve for x. Well, I'm going to add x squared to both sides to solve this. I get 9 is equal to x squared. I take the square root of both sides, and I get that x is equal to plus or minus 3. So I have two things that I can't be here. I can't be a positive 3, and I can't be a negative 3. I like making interval notation from a picture, so we're going to graph what this means. If this is a real number line, what it's telling us is that, hey, you can be any number that you want on this number line, but you need open circles at negative 3 and at positive 3 because you cannot be those numbers. Well, the interval notation of this, so the domain of f, which is the interval notation of this, is going to be from negative infinity to negative 3, parentheses, I union it from negative 3 to positive 3, parentheses again, union from 3 to positive infinity. So the domain of this function, again, is negative infinity to negative 3, negative 3 to positive 3, union 3 to positive infinity. Let's look at example 2. Again, it's a rational function because it's got a fractional bar there, so you set that denominator, which is 8x cubed minus 2x squared minus 3x equal to 0, and you solve for x. Well, I can factor out an x, and I'm left with 8x squared minus 2x minus 3. I can factor 8x squared minus 2x minus 3. Let's see, that's going to be 4x and 2x and 3 and 1. So you're looking at 4x minus 3 and 2x plus 1. Set each one of these equal to 0 and solve them all for x. Here x is equal to 0, then 4x minus 3 is equal to 0, 2x plus 1 is equal to 0. So x is equal to 0, already solved. 4x minus 3 equals 0. If I solve for x is going to be positive 3/4. And 2x plus 1 equals 0. If I solve for x is going to be negative 1/2. Right, again, let's put these numbers on a number line so we can get our interval notation for our domain. I have to put a slash at negative 1/2, put an open circle, at 0, and at 3/4. So what it's saying is that I can be any number except for those three numbers. So let's write the interval notation of this. Well, the domain of this function f is going to be from negative infinity all the way to negative 1/2, parentheses, union, from negative 1/2 to 0, union, from 0 to 3/4, union, and finally from 3/4 to positive infinity. Alright, well, how do you find the domain of an even root function? To find the domain of an even root function, we have to split this up into two separate things. If that radical is in your numerator, so if you have something like example 3, where the radical is in your numerator, what you do is you set the expression under the radical greater than or equal to 0 and solve for x. Let's do number 3, and then we'll look at the other thing that you do if your radical is in the denominator. So I need to find the domain of f of x is equal to the square root of x squared minus 3x minus 4. Because this is in the numerator, well, how do I know it's in the numerator? Remember, we can put anything over 1 and then automatically it's in the numerator. But if it doesn't have a denominator, then by default it's in the numerator. So I set the expression under the radical. Well, the expression under the radical is that x squared minus 3x minus 4. So I set x squared minus 3x minus 4 greater than or equal to 0, and I solve for x. Well, this is a polynomial inequality. And we know how to solve polynomial inequalities. What we do is we graph them. So in order to graph, I need to know the degree. Well, the degree of this function is 2, so that makes it even. And the leading coefficient, well, the leading coefficient of this function is 1, which makes it positive. So my end behavior is going to be up and up. Then I need to know the x-intercepts. Well, if I said x squared minus 3x minus 4 equal to 0 and solve to find the x-intercepts, this factors as x minus 4 times x plus 1. So I get x is equal to 4 and x is equal to negative 1. Well, what's the multiplicity of those zeros? Well, here my multiplicity is 1 and there my multiplicity is also 1. So let's quickly graph this function. So there's negative 1 and 4, and behavior is up and up. We know at negative 1 we need to cross because our multiplicity is 1. Intuition says get to the other point. We get to the other point, which is 4, and we're supposed to cross. Then we need to go back to the inequality and figure out how to answer the question. This is asking where we are greater than or equal to 0. That meant above or on the x-axis. Where am I above or on the x-axis? All the numbers over here and all the numbers over here to the right. So the domain of this function f is going to be that interval notation that we can get from that picture. Well, that is negative infinity to negative 1 with a bracket because of that or equal to bar union 4 to infinity. So again, when you have the radical in the numerator, you're going to set the expression under the radical greater than or equal to 0 and then solve the inequality. Right, let's look at the next one that we have, part 2. Part 2 says, well, if the radical is in the denominator, what you do is you set the expression under the radical just greater than 0 and solve for x. Well, the reason that we just set it to greater than is, again, if we're in the denominator, we cannot be equal to 0. So let's take a look at example 4, which is just like that part. So I take a look at this, and this is a rational function, but it's got a radical in it, and it's an even root, because remember, if there is no number in there, my root is 2. Well, I set the expression under the radical, which happens to be 3x plus 1, greater than 0, and only greater than 0 because it's in the denominator, and solve for x. Well, what kind of inequality is this? Well, this is a linear inequality. Well, linear inequalities are easier to solve than polynomial inequalities. All we need to do is isolate the variable. So let's go ahead and isolate the variable here. So I end up with 3x is greater than negative 1 dividing by 3, x is greater than negative 1/3. Well, let's put this on a number line so we can get our interval notation. Here's negative 1/3 on a number line because it does not have an or equal to bar. It's an open circle, and I need the numbers that are bigger than negative 1/3, which are going to be the ones off to the right. Well, what's the interval notation of this? So the domain of this function, because of its open circle, it's going to be parentheses, negative 1/3, comma, all the way to positive infinity. The next video is going to deal with when we have two different things going on, a radical and a denominator.